Oh, nope, that didn't work. Huh. I don't know what's going on. Oh, here was the, if you weren't here, I'll tell you this. You weren't here that day. That was one of the problems I really, really liked. I did two problems where I said I really like that problem, which pretty much means you're going to see something like that on the quiz. So those are not necessarily book problems. I found that when I was working on what lesson we were going to do. So if you weren't here for that, you need to go back and watch that video. Oh, can't control with that. What am I thinking? And I, be honest, I don't remember what the other. There she is. They tell you or you? Okay. Yeah, he just dropped it. This is his last name, Roddy, I think. All right, so I'm gonna do number 8, and there's really not any like when I say I'm gonna do it, I'm gonna tell you the answer to it, but I'm also gonna show you why that's the answer. What's the answer on number 8? Well, what is the problem, first of all? I don't know. It's quiet. So that's the question. What's the answer? What's the answer? No, you already. Seriously, don't be scared. Some of you have an idea. I know some of you have the wrong number in mind. You're scared to say that number. It's one of, hopefully, you know, it's one of two numbers, but a lot of you are thinking the wrong. Don't be scared though. If you're wrong, you're wrong. You're wrong a lot in life. Somebody said the correct thing. Somebody raised your hand or no. No. What? What? So it's one, right? Isn't that weird? Like, some of you are probably thinking 0. Raise your hand. Be honest. Are you thinking 0?
Yeah.
Some of you are thinking 0. I knew you were. Because you think, well, and you should never multiply an exponent times the base anyway. But how can I, if this is the base and this is the exponent, how can I say the base times itself 0 times? Like that doesn't make a lot of sense in this scenario. So I'm going to show you why that's the answer, and hopefully then it'll stick if it doesn't already solve. Did we do a problem like this? Where we had a quotient? I know it was one of the problems 5, but did we did it in class, right? Okay, let's do that real quick. There's a rule you can use called the quotient rule, right? I'm going to show you why that quotient rule works first. What's 3 to the 5th mean? So 3 times, I mean, again, if you understand, again, not even the rules of exponents, just what an exponent is, and you know that product rule, I'm telling you, you will be fine on exponents. Same concept down here. That's it, right? Pretty similar. Just do a little long. I can now say, well, wait a minute. This is just that situation where I can cancel some stuff out. I cancel that out. Now I can go back because I want your answer in the format of a base and an exponent. I can go back and use the product rule. 3 to the first times 3 to the first means I just add the exponents. I get that. That's the rule. So the quotient rule says if you are taking, again, has to be the same base. So we had the same base, kind of like when the product rule, we said it had to be the same base. Instead of adding the exponents, though, you take the top exponent, subtract the bottom exponent. You know where you're going. Thinking the same thing, right? You didn't feel it? Anyway, so this is now how I'm going to teach you that this is why the 0 thing is 1. So 3, and I'm going to change the exponents for no particular reason. 3 to the 4th over 3 to the 4th. Oh, not, then see, then I, oh. So what were you thinking? So what would you get? The rule that if the rule is you take top, subtract bottom, then that's the rule. So what would you get? That's actually number 11, maybe, in your book. Isn't there a negative exponent somewhere? It's 13. What part? Well, one of them I know has a negative exponent because I did it yesterday with 6. So we'll get to that one next day, right? So now, because we're still on the 0 thing, why in the world is an exponent of 0 1? So if I know again, I'm glad you mentioned this. This is the thing you got to understand about math. The rule never changes. I don't care how weird it looks. If the rule is I take the top exponent and I subtract the bottom exponent, that's the rule. Don't freak out if you get a number that's weird as the exponent, like this. The rule is I take the top one, subtract the bottom one, then that's what I do. I'm going to go ahead and show, since Emma asked about it. If the rule is, oh man, I wrote that. Not as much space in that. I'm going to write small. If you can't see it, let me know. That problem 7 is. I think I made it up. What did we just do? Yeah, I'm kind of making some numbers up just to. I do that sometimes. So if the rule is I take which exponent and subtract which exponent. Doesn't change just because this is now the bigger number. It does not change. So it's 3 raised to the 3 subtract 6. I get a negative exponent. Now there's something we have to do with a negative exponent, which I will get to that in a minute. Actually, no. We'll do that too in a minute. But first, let's go back to this. And this is why I told you, I don't ever get distracted. So ADHD. If you understand what an exponent is, and if you know the product rule, you don't need any of these. I don't need to memorize what I'm about to tell you about this. I don't even really need to memorize what something raised to the 0 power is. Because now let's break it out. Nobody needs that. Wait, I mean it. Oh man. I mean that one I can come help you with if I need to. So now let's say we didn't know the rule. What's 3 to the 4th? Mean. Not calculated out, but what's 3 to the 4th mean? 3 times 3 is fun. You notice I'm going to beat a dead horse on that, because if you know it, you'll be fine. What it means, right? What can I do now? That goes to 1. That goes to 1. 1, 1, 1, 1, 1, 1, 1, 1. So what do we get? That's why anything to the 0 power is 1. Because you're always gonna, like, if you went backwards, the only way to get something to the 0 power is to have the same exact term divided by the same exact term. It's the only way. Because you'd have to be subtracting numbers that are the same, exponents that are the same, which means that if the exponents were the same, it's the same thing over the same thing. Can't go away to 0. Was anybody waiting? All right, so work for a minute more, and then I'll come back and do that negative. I'm still going to do the negative one, although I think that's probably the one most people are on. I think I'm not. Logan just asked. Try to, tell you what. See the problem. Oh, I don't have it. Okay. I know. Funny thing is, I was not like this. Oh, let's see. Which one is it that had the negative? The first one with the negative 12. That'd be a tough one to try to break out just yet. So try to do 11, 10 if you haven't already done them. If you have, as soon as I get this pass written, I'll probably go ahead and do that. All right. Yep. Yeah. Tell you what, keep working until I'll answer a couple questions first. Okay, so that's kind of like what we did on the 3 and the 3 and the 3 and the 6. So what would you do? What do you have on top? So 1 on top. What would you put on the bottom? I want it in the format of a base and an exponent.
That's it.
That's it. All right, so now keep this in mind. We know what the final answer is with a negative exponent, right? 3 to the negative third. Remember, that's what we had. And I guess I can write it down. I'm gonna actually, yeah, I'll just work it out down below. That'll work. Oh, I hope anybody need that. I mean, I can go backwards if you need it. All right. So now again, let's think about the other way to solve it. What would we do?
That.
Jocelyn, what do I do? The other way to solve it if I didn't know the rule. Because again, I'm telling you, you don't have to know any rules except for that one product rule. So what would you need to do? And you have to know what an exponent is and that kind of stuff. Yes. What's 3 to the third mean? We're doing this one. We're doing it a different way. What's 3 to the third mean? Yeah, again, I'm going to beat a dead horse on that because you need to know that immediately. There should be no thinking about it. You can do every single problem breaking it out like this if you know the product. That's one you do have to. Over. What's on the bottom? Six threes, right? What can I do now? All those go to ones, so I still have to write the 1 on top. That is equal to that. So when you have a negative exponent, so now you're lost. I'm bringing you back. That doesn't look right. If you have a negative exponent, in math, we don't like negative exponents. It's not like, what's the word? It's not the correct format to write it in. It's kind of like a grammar thing. It's like using slang in math. We don't like slang in math. That's math slang is a negative exponent. So we need to convert that and get rid of the negative exponent. So what you do is you take the term, you put it as the denominator without the negative, so 3 to the third becomes the denominator, and you put it a 1 as the numerator. Always, like that. That's what the rule, it's called the negative exponent rule. I showed you why it works, and frankly, you don't have to memorize it because you could always just do it that way if you wanted to, break it out and then combine it back together just like we did here. You could always do that, but if you want to try to memorize stuff to save you time, the way you change it, take all of this and put it in the denominator without the negative. There's no negative down here, and then make 1 the numerator over. Did you already ask? Oh, then I'm going to go ahead and let you know, unless you guys want to work that out. She'll be fast. I don't know. I know pretty much all the names now, but not necessarily all the spellings. So any questions on that? So now you should be able to do anything with a negative exponent in it. And that might be the last thing you needed to know to be able to do all of them.
Wait. Yeah, I was just gonna say that.
I want you to try to do 10 is not bad at all. The only halfway tricky part is how to handle the negative part of it, but you know what an exponent means, right? take the base and you multiply it that many times. So you're going to write it all out. So that'll be one where you are going to want to write it all out. You're going to have a bunch of numbers on top, a bunch of numbers on the bottom, even though technically it's going to look like all individual fractions. It's really not. It's really a bunch of numbers on top, a bunch of numbers on bottom, and then cancel them out. And then just be careful with the negatives. I will do it, but I want you to try it first. I'm not just going to immediately do it. Tell you what, I'll give you what the answer is. Let me look at it again. And that way you can check it. If you don't get it, you can try it again. Oh, actually, I'm also going to give you a really. Huh. Guess I made it up. So I'll also make one up and show you a shortcut so it'll work sometimes. All right. Thank you. But try to do, I mean, you should be able to do really the rest of them. I'll do a couple of the even ones, but. I'm talking about the rest of them in that section. So, thank you. You're getting the codes.
All those in that section.
You guys have been super fast, so I just want to make sure I get my passes. Oh, you did it. Favorite student. Hmm? Oh, no, you wanted to. Right. Oh, man, this is the only class where I have so many people. Yes. Second favorite. The joke. Pretty much everything I say, you'll know I'm serious. Fifth period. They definitely know I'm serious.
I know. Usually.
Skip it. Go to another one. I'm going to work the two. So I'm going to work in a minute. I'd like you to try them first. I'll just sit there and see the answer. I'll probably do 10, 12, 14, 16. So try to do those first. Always check your answer on the odd ones later and do those on your own. We need to get through today. I'm not going to do, I may not do anything on the quiz about scientific notation. It's not that it's not important. It's just, frankly, it's in the calculator. So like there is a way I could do it, but I probably just won't do it. Don't worry too much about 37 through 44. And we're gonna stop at 44 today. So I want you to keep working and do as many as you can all the way down through 36. 31 through 36 is the same thing I just showed you, only there's no numbers in it. You're just dealing with variables. So you just have to do the same thing with all the variables. Well, actually, some of them do. You know why that's a separate section. Yeah, that's weird. You should know how to do number 17 through 20. You're just plugging in a number and solving. Although you do have to know how to do it correctly. I mean, they're all the same. Like everything all the way through 44. We've done it all. It gets a little trickier, but there's no new information I need to give you to do them. Raise your hand if you are already finished through 16. I'll give you another minute or two. Shouldn't take you much longer to get through those. Even if you don't necessarily have the right answer, you should have an answer for the even ones. That's do it with somebody. I to bring my. Oh, I should just have a board here with a pen on it. Then when I don't have a pen. Oh boy. We're gonna start. And 3 and 4 minute average time. Let's walk around and see how we're going to handle it. I know you came from another class, but I feel like this is definitely stuff you should know how to do. So I'm still gonna have you. So for both of you, if you're so I record the videos. That's what I'm doing right now. That's what I'm doing right here. If you didn't know what I was talking about. So for the stuff that you missed, feel like you need to go back and watch it. I go through problems just now. It's on YouTube. This is the directions to get to it. Go to YouTube, type in Mr. Gill Geometry. That's the main class I teach. Look for a picture of a dog's face. It looks exactly like that. You go to that, and then it's by date and time. And then you got to look for this class because I don't. Some of them are geo, and then the same thing. So, and then you can watch the videos. First, oh, and just walk around. Stuck? Keep going. You should be able to do some of them past that. They repeat the same types of problems for the whole rest of the day. Probably again, right? Because again, don't sit there and do nothing. If you're sitting there and you're stuck, when I get there and you say I didn't know how to do it, but yet you haven't raised a hand, I'm gonna have an issue with that. So there's no reason I should get to your paper and you're just sitting there doing nothing. Either you know how to do it, or you're asking me for help. Those are your two options. You can do them if you want to try. I mean, this kind of stuff will be on SATs and ACTs and stuff. I'm not going to put on my stuff. Let me clarify that.
No.
So real quick, let me clarify something. Like when I say I'm not going to do anything with scientific notation, that means it won't be on the quiz I give. It's going to be on ACT, SAT. I think they actually really like those. But I don't know why. But I would guarantee you there's going to be something with scientific notation on an SAT, ACT, for test. So don't, like if you're just done with nothing to do, go ahead and try to do it. Well, I don't want you to use a calculator. There's no, like, I want you to give me an answer with use the negative exponent rule that we use. Really, all you have to do is what we just did here. So your answer will be something like that. That's all. That's all I get it. It's pretty much a one step and you're done. Thank you, ma'am. All right. All right. I saw quite a few people that looked like they were through 16. A few people weren't, but I'm going to go ahead and let's do 12, 14. Oh, we need to do 10 also. All right, so we'll just start at 10. All right, so number 10 is negative 3/5 cubed 5/3 squared. Really quickly, there's a gigantic difference, if I haven't already gone over this, between this and this. Actually, there's a really gigantic difference between that. If you don't have those parentheses, it is treated a totally different way, even if you use calculator. So you'll get the wrong answer on a calculator if you don't have these parentheses in the problem. Or if you do have the parentheses, you'll get the wrong answer. Like, there's a certain way you have to do the problem. So just make sure you understand, like you understand how to do it, then you can kind of check whether or not you're doing it correctly in the calculator. And then was it 5/3 squared, right? All right. So guess what I'm going to say? Start off. Same way I started every single exponent problem out. What does negative 3/5 to the third mean? Yeah, well, negative 3/5 technically, but yeah. So that's a good point. Let's talk about it now. This means I'm taking the negative with the fraction and multiplying that out. If those parentheses weren't there, I'm actually not using the negative when I cube the number. I'm cubing positive 3, and I'm not even cubing that. I'll show you what that means first, because that's not the problem. If I have that, this 3 only applies to that, and it only applies to that positive 3. So it's done very differently. So I would actually have 3 times 3 times 3 over 5, and that would be a negative number. Whereas here, we're taking negative 3/5 times negative 3/5 times negative 3/5. Parentheses make a huge difference in exponents. So there's a problem where kids, I think it's an odd one because they were checking their answer, they kept getting the wrong answer, and it was the sign was the only thing that was wrong. It's because of that concept. Like, for example, if I square negative 3/5, like with parentheses, if I square that, I get a positive number. It's a negative times a negative. If those parentheses are not there and I square it, I get a negative number because I square the 3/5 first, then I bring in the negative. So you'll see it when you get to it. I'll tell you which one it is. It's might have been in the problem right here. Yeah, number 11. So if you got the wrong answer to number 11, that's why. You're squaring the 3. Everybody just look at number 11. It's a pretty easy one. I don't really get into it. In number 11, it says negative 3 squared. No parentheses, right? There's no parentheses around the negative and the 3. So you're squaring 3 first, because that's the order of operations, right? Exponents first. You get 9. Then the negative sign comes back into play, and you actually get negative 9. That is not positive 9. So if you were not getting that one correct, that's why. Got to be parentheses around it to actually square the negative. So negative 3/5 times negative 3/5 times negative 3/5 times 5/3 times 5/3. So even though it's broken out into individual fractions, yeah, you don't need to see that's in the book, so you don't need to see that. How do we multiply fractions? What is the way you multiply fractions together? What do you do? The easiest thing you do with fractions, because you don't need a common denominator. You don't need any kind of factor, nothing. You just do what? Don't even need to flip anything. That's division. You divide fractions. You need to do the easiest thing you can do. You don't add, you just multiply straight across. Yeah, if you're multiplying, you just say, okay, well, that's -3, and you can include the negative. I would include the negative with either the 5 or the 3 when I do it. I wouldn't keep it out in front personally. The key is you just need to know that the sign, a negative times a negative is a positive. A negative times a positive is a negative. You just need to make sure you know the rule. So I would say, again, I'm going to keep the negative sign with the 3. That's the same thing as -3 times -3 times -3 times 5 times 5. You're just multiplying the top straight across, and that is divided by, and now I don't use the negative again. Once you've used it once, you don't also put it on the 5. One negative cannot become two negatives. So that's really all your problem. Same thing we did before. Now you can cancel out terms that are on the top and the bottom. Really simplifying, dividing out or simplifying. So that 3 can cancel with that 3. Again, I'd have a 1 there and a 1 there. That 3 can cancel with that 3. 1 there and a 1 there. That 5 and that 5, that 5 and that 5. So what do I have on top? Negative, good, because I do have to bring back in now the negative rules. -1 times -1 is positive. +1 times -3 is negative, and then times 1 doesn't change it anymore. If I get -3, and then what do I have on the bottom? +5. So if you rewrite it, once you write a fraction, you do typically put the negative out in front of it, not. So that's the answer to 10, was it? Let's just go ahead and go real fast through 12, 14, 16 instead of me stopping. Oh yeah, and 12 is fast. Uh, let's do it down here so I have all of them on there. I know I'm not prepared to book. So -4 again inside parentheses to the -3rd. I'm just going to use the rule for that. What do we do to get rid of this negative? Because we never want to write something with a negative in the exponent. What was that rule? We're going to make it a fraction. So it's always going to become a fraction. 1 will be the numerator, and what's going to be on the bottom then? So the exponent will be 3, but the base doesn't change. It's still the exact same thing as in the original, just no negative. So that's all I want you to do. That's all I want you to be able to do for that.
That's it.
Yeah, that's it. That's final answer. That's it. That's the way I want you to write it. They, I think, in the book probably have you multiply that out on the bottom, but I'm not worried about that. I'm assuming you can plug a number into a calculator and get it in. So now look at 14. Must have made up the problem I'm thinking of, because I sure don't see it in any of these all the way through 36. All right, so I'm just going to do it again below that. I'll change colors. So 3 over 3 to the -4. Now this is a little tricky. Anybody think they know how to do it? What do you think?
I don't know.
Well, you don't change it to -3. So that's a great point. I'm glad you mentioned that. Never take this negative and make that 3 negative. Would never do that. What do you mean switch it back to a regular? So we want a positive exponent. Is that what you're saying? Yeah, we want to get rid of that first. again, we don't want negative exponents. So 3 doesn't really do anything on top. That stays there. 1 over 3 to the 4th. Now, though, we can't leave it like that. Like, that's really weird. You want something that looks a little simpler than that. So what would we do? Any idea? Hmm? Break it down. Like how? What does break it down mean? Because what is that problem saying? Edgar. Edgar, what's that problem saying? Can you read this problem? What's over mean? So it's 3 divided by, and then we'll just say 1 over 3 to the 4th, right? So what did we say we do when we divide? We're dividing, it's kind of a fraction divide. Actually, we can make it a fraction divide, I think. 3 divided by 1 over 3 to the 4th. How do we do that? And we change, what do we have to change besides flipping the second bracket? We need to change, it's no longer division if we're going to do it, right? So this doesn't change, 3 over 1 times, this was keep, change, flip, I think we went over that. And then I'm flipping this to be 3 to the 4th over 1. So if I'm multiplying two terms with the same base, then I just add the exponents. So 3 to the 1st times 3 to the 4th. And it's over 1, but anything over 1 is just the same. I'm not. So that's the final answer for that, 3 to the 5th. And then last, we'll do 16. I mean, last for now. We'll do 16. I mean, I feel like that's almost the same. Yeah, not exactly. We'll do this one. Actually, we'll do this one in black. So 3 to the negative 2. If you haven't tried this one, try it now. Because a lot of you maybe didn't quite know what to do. But now that I've done a couple of other ones with negative exponents, if you haven't tried that one, that's one I definitely feel like you should be able to do based on us doing all the other ones we've done. So, because you should know what an exponent means and what you would do, and then you should know how to handle a negative exponent. I'll give you a minute. So Friday, we're going to get into roots, meaning like square roots, cubed roots, radicals, all that. But you are responsible for 21 through 36. Make sure you're working today and asking any questions on those. I'm not going to get to a lot of those. Probably won't be a ton of those. I'll focus more on the ones that we've gone over, but you know how to do all this. Prior knowledge you're supposed to have. That's the negative exponent rule. So we said anytime you have a negative exponent, we get rid of the negative by putting a 1 on the numerator and by putting the positive version of it on the bottom. That's what we did it. Did an example of why that's the case. Oh yeah, here we go. Here. So if you break this out, right? So the rule is 2 subtract 4 is negative 2. That's the rule. Top subtract bottom. But if you break them out, don't you wind up with 2 5s on the bottom? That's why. Let's start. Yeah, so what would you do now? Which means that you're really doing what? Yeah. And then there's one more step to finishing, which I'm about to go on. So there's actually two ways to do this. I'm just going to pick one, but I'll explain the other one. I have the option now that technically, what should I do first? Do I know technically what I should do first? I got to call on for this. Oh, I got to remember a name. So I call on. Starts with a K. Here. What do I do first? Technically, what should I do first? Why? It is correct. Why? Why'd you start with that? Huh? But why are you starting with a negative? Is there a reason why you did that? I'm just curious if you know. Why would I want to start? Why would I start with the negative in here instead of just using that? Because I know what an exponent means, and you could do it that way. It comes out the same. Technically, why would I start with the exponent first or the negative first? What's the order of operations mean? So what's that first letter? So what's in parentheses? That. That's why technically you should start with the negative exponent. Because parentheses is first, so we do what's in the parentheses first. All right, so with that in mind, I'm going to do it that way. So I have, what do I, actually, let me call him. Jair, I haven't called on Jair. Happy birthday. Happy late. What do I do inside those parentheses? So it's going to be a fraction, right? So what's it going to look like? What's going to be on top? What's going to be on bottom? No, that's how we're getting rid of the negative, right? Making this into a fraction is how we get rid of the negative. So what's going to be on bottom? Everything else is the same. Just get rid of the negative. What's on the bottom? I can't hear you, but I'm sure you got it right. That's on the bottom. So by changing it to a fraction and putting 1 in the numerator, that gets rid of the negative, but we still need the 3 squared part. It just goes on the bottom. Right? So that's how you change a negative exponent into a positive. Now, I still have the squared. Haven't done anything with that yet. Now I can say, okay, well, what does this mean? Ryan, right? What do I do now, Ryan?
You take the outside exponent and multiply it by itself.
So we take the base and multiply. So this tells me to take the base times itself twice. Now using my product rule, I have the same base, and I just, again, it's a multiplication problem and a fraction. I multiply straight across. Straight across the top is just 1 times 1. Straight across the bottom means I add the exponents because I have the same base. So 1 over 3 of them.
Oh, that's why I was studying.
Yeah, again, so remember, when you do these problems, show all of your work. Because if you happen to just get the wrong answer, but everything else looked pretty good, and I felt like you got the concept, you don't really lose that many points. So make sure you're showing your work. Yeah. Oh, yeah. 30 minutes. What do I do with the pass? Over 2. What number was that we did? Was that 16 or 14? It was 16. All right, so keep working then. Like I said, you really should be able to do the rest of them through like 36. They have a bunch of variables. They look a little different, but I'll come back and we still have 30 minutes, so I'll be able to do 1 or 2 of the problems. Probably just let you guys pick. I'll be able to do 1 or 2 of the problems between, I'm not going to worry about 17 through 20. So you can check 17 and 19 and make sure you're doing that correct in the back of the book. I will probably do 1 or 2 from 21 to 36. I'll let you guys, so make sure you're working through them. If you get to one you can't do, then you may want to, or if you just want to do an even one and have me do that to check your answer, that's what you're responsible for from today, for 36, basically. Either struggling on math or struggling to stay awake. Like, wait. Oh, that was an evaluation. So here's an, if there were no parentheses, this would be probably if you're not squaring the 7, which doesn't look like here. So that's a for the -2. Can you put it over 2? Probably can. I'll make it. So that's another reason why I'm making put it in the answer form of the base that question. Yeah. It's actually one of my degree. Now. So I'm actually just about to test out and see if it lets you put a negative in the calculator. Good. Good.
And then exporters.
Oh no, you're just agreeing with that one. 4 raised. What would be the let's see where. Oh, that. Oh, your negative button's worn off. Yeah, it does. You can actually put a negative exponent into your calculator. Now it doesn't give it to you in the format I'm going to want it, but depending on how the ACT, SAT gives you answers, I mean, I don't know if you necessarily get all these calculators. I can show you how to do it. I guess I can, because I'm going to make you put it in a different format for the answer. So here, really quickly, if you want to look up here, if you want to raise a number to an exponent on these calculators, and it's not squaring it, so it needs to be higher than 2. Do you guys know how to do that? How do you do it? Perfect. Yeah. This little, I think they call it the caret symbol or something. That little symbol is the one that raises it. No, it's not like that on most calculators. So does anybody have the white calculators? Anybody using that? Or have your own? Does anybody have this button? Actually, I don't know the way it looks. It's one of these two. It's either X to the Y or Y to the X. Does anybody have that button on their own personal calculator? Because that's normally the button that does raising a number to any exponent. You would put your base number in first. You would hit this button, whichever one it is on the calculator. I don't know which one it's normally. And then you hit the exponent. So this is pretty rare. That's not the normal exponent button on a calculator. I was surprised to see it on here actually when I first saw these. It's typically this one, but you do the same thing. So if so I actually did this number. Wait, no. I actually did. What problem? Who was I just talking to that had? Was it 18? Yeah, I think it's 18. So yeah, 18. I'm just gonna pretty much do 18 for you. And then it wants you to evaluate that if X is 4. Now we could use our knowledge of negative exponents and we could change that, which is what I would like you to be able to do. And we'd say, well, that's 7 times 1 over X squared. Well, now you could plug 4 in, and it would be 16, and then you'd say 7 times that would be 7 over 16, and leave it as a fraction. That's the way I would want it on my quiz. Let's say it's not like that, though, and it's decimals or something. You can actually plug 4 straight into this. So 7 times 4 to the negative 2, and you can put a negative exponent. Just hit 4. So hit the number 4, hit that little caret button. The negative sign is like down and left of the enter sign, the equal sign. It looks like this. And then you put the number 2 in for the exponent. And then hit equal. I think you have to hit equal. And that will take this part and change it into an actual number. And then multiply that by 7. I'll probably stay away from things that are calculator problems, so I probably won't have anything on there like that. That's pretty much a calculator problem. What did you get? What, that was an even one, right? Yeah, 18, I said. So what did you guys get for that? So we can all check our own answer. Number 18, what did you guys get? What was it? Oh, you're working on it? Did you do it? What was it? Oh, I think it'll show it as a decimal though. I was trying to get I mean, we could divide that out. I guess. So what, if you do it as a fraction, it's just that. I want to do, it's what? So 0.4375 if you did it in your calculator and it gave you a decimal. It might give it to you as a fraction when you do it. I don't know. Yeah, so either way, it's one of those two, depending on how you did it. Let's walk down this. Problem. I'm super talking about Alzheimer's. What I told you. Oh, you're doing that. Yeah. Actually,
The doctor was
yeah. Right, a lot of you are kind of floating right around the number that I'm doing, so make sure you're not just waiting for me to do something, because again, you're not getting it, that's fine, but you're also not asking questions to move forward. That's not fun. I grade these quizzes. Did you look it up in that? Yeah. So again, if you weren't here when I told you, so you see how these pages are a little bit gray. That's the answers. You can kind of even see where they start. Like, that's just a little bit darker, so you know exactly where to go to, kind of. So you do start on the page and I make it down. So what is it? Section 2, 17 is that. So try it. So now that you know what it is, go back through and try it again, maybe even a different way, or if you were not sure how to do something, try something different. And then if you can't get it again, let me know. Either. So what? That's I'll do that. Try to do it, see what you get. Because I do like that because there's multiple ways to do it. And it's a the other ones are a little more complex. That one I would expect everybody to do. So I'm going to do 21 in a minute, even though it's even. I'm trying to say no. I'm going to do 21, although you can look the answer up. It's still a really good problem for me to do. So, like normally I only do the even one, but that's one I want to start. You. I totally.
The tape on your back, right?
Well, it's better than on my head, which is where they were an hour ago. Yeah, the girls were helping me put up flag posters for the thing, and so the tape eventually made its way up. But thank you. Yeah, I don't know where it's at, so I didn't know. I know it's there. Yeah. Oh. You were gonna play flag at one point, I remember. You could do it. You could do the free league or no practice or anything like that. Everything else. No, starts next month. Yeah, we don't practice or anything. It's just to go out and have some fun playing flag. Hey. You. What other good ones are there? So what number was that again? Ari?
17. I got it.
Oh no, that was not the one I was talking about. Where was 17? Okay. 20, 31. 31, right? Callie? I think it was 31, right? Yeah. I'm gonna do 31 in a minute or two. Actually, yeah, we'll do it now. Emily, you can show Aaliyah when I was gonna wait for her, but you can show her when she gets back. Because I do like that one a lot. Anytime I tell you I like a problem a lot, one you need to make sure you can do. The reason I like it a lot is there's a couple different ways to do it. So that way it gives you guys options. Let's go back to red. So everybody look at number 31. Again, it's not one that I think is super complex. That's not why I'm doing it. I'm doing it because it's got some options on it and a few different rules all in one problem. So there's a couple rules going on right at the beginning. Medium. I've got this negative exponent thing, right? And we don't like negative exponent, but a negative exponent tells us something we can do. So what could I do? What is the negative exponent? If I wanted to get rid of that, what would I do? I can change it to a fraction. So I would treat this as the base, that whole thing. I would put that on the denominator. Yeah, I'm gonna need this. And then what would I do? What would I do then? There's actually a couple of things that I still need. Say it again. Ooh, I don't like that answer. I'm getting rid of the negative. How do I get rid of the negative? What was it that we did when we did those negatives earlier? So what do I need to do to make that a fraction? Look at the ones we did. We just did like 3 of them. Look at one that started with a negative exponent and then became a fraction. So where's the 1 go? So there we go. I got rid of the negative. There's one rule we took care of. Anything else I need to do? Do what? So let's go back. Why are we doing that? What did I forget? What have I not written? Yeah. I didn't write this exponent in. Don't forget. Because here's the reason I'm doing this. A lot of times kids see that 2 and kind of forget there was also a 2 there. Don't forget to bring down the whole term. I mean, literally all we got rid of out of all of that is that negative. And that's because we put a 1 as the numerator. So don't forget to write everything in there as the denominator.
Wait, so that's it?
Well, no, there's more. Now there's another rule or another way we could do it. What could I do now? A couple different options. Right. So this 2 down here is telling us that we take the base and we multiply it times itself, right? Now, it doesn't really matter in this problem, but it could have in another problem if we had a different numerator. It's technically not telling us to do this. It's not telling us to do this. That's not what it's telling. The 2 is not on the whole thing. It's not around the 1. Now, it wouldn't have mattered in this problem because 1 times 1, it's just going to stay as 1 anyway. If we did it wrong, we would have still gotten it right. But just understand what it's telling us to do exactly. Ooh, it's going really fast. There. So what it's telling us to do is just change that into 1 over 2x squared times 2x squared. And the square here is only on the x. It applies to the x, not the 2. Now I can combine stuff using the product rule because I'm multiplying terms. I have technically this is really 2 times x squared times 2 times x squared. So I have 2 with a 1 on it and a 1 on it. Don't forget that. There's no exponent. Again, this 2 does not apply to that 2. There's a 1 on it. Make sure you keep that straight. That's a mistake I see a lot of times too. So if I kind of go down and convert that down there, 1 still on top, nothing changes there. 2 stays as the base, but I add the exponents. And then for x, x stays as the base, but I add the exponents. That should hopefully be the answer in the back, because that was an odd problem. Oh, did they say they made it 4? Yeah. I want you to leave it in this format. Don't they? The book has it as a 4. I don't want you to ever Question? That face tells me you have a question. I don't ever want you to multiply out the base multiple times. I trust that you can do that in a calculator. I want to see it in this format, so I know you know the rules now. Now, I will tell you there was another thing we could have done way back in the beginning. What's another rule we learned that we could have actually applied when we have an exponent raised to another power? Rule we learned, power to a power. Yeah, we just multiply the exponents. I could have, from the very beginning, I didn't even need to do this first. We'll get the same exact answer. Go, let's do it in blue. I could have said -2 times 1 is 2 to the -2. -2 times 2 is x to the -4. Because that was one of the rules we learned. We kind of did it this way first when we learned that rule, and I showed you that it would work. But that's the shortcut version. Now I would do this. Now I'm doing the change it to a fraction part as the second and third step instead of as the first step, but we get to the same spot. 1 over 2 squared times 1 over x to the 4th equals 1 over 2 squared x to the 4th. So we get the same answer no matter how you do it. And as long as you work through and show the different steps, I don't care which way you do it. So whichever way you want to do it, it's fine with me. Any other questions on that? See a lot of faces that look kind of confused. Again, pick one. If you're confused by one, but you get the other one, then don't worry about the one that confuses you. They get you to the same spot. So don't worry if you're confused with one of them, as long as you get the other one.
The two X's.
Wait,
Right above it.
I got a lot of 2x's though. Which 2x?
At all of them.
Oh, one. Exponent of one. Is that what you're talking about this? Yeah, remember, if there's not an exponent on a number, on a variable, it doesn't matter. Every single exponent or a number has a one in there if you don't see an exponent. Oh. Let's see which one. Well, God,
Yeah.
I went fast. Holy cow. Real quick, then I'll do one more. Does anybody have one they want me to do?
Wrong.
Don't have time.
Can you do 37 or no, it's not the number? Like 25.
25. All right, we're gonna do 25. Somebody said another one. If we have time, we'll get to that. 25, you said, right? All right, so 25 is pretty fast, so we'll probably be able to do two of them. All right, so everybody look at 25. If you didn't get if you checked and you got it right, then you're good. X squared. This is actually one that's better to break out and do instead of use, in my opinion, do the rules. Now they may have the answer in a different format. That may be what confuses you, but I would think of it. And again, I want you to write this stuff out for now. Obviously you can, whatever answer you get on an SAT or an ACT, you won't have to do all this, so it'll be faster than you think. So now that I've broken that out, I just do the whole canceling thing out. I can cancel out variables just like I can cancel out numbers. I have an X and an X there, I cancel them out. X and an X there, I cancel them out. I would imagine that's the only way.
But it's not just the X, but
Oh, yeah, great point. I'm glad you mentioned that. So you've got to remember that if there's no parentheses, the exponent on the 7 is 1. The 2 only applies to the X. What was the other one? Somebody yelled 30 something, I think. 36. Oh, the last one. All right, so we'll go back to a different color in case I scroll through it later. So X, again, it's variables, but it's still, I'm going to break it out. Oh, X to the n, that's good. All right, I don't know that I'll get this one on the quiz, but it's a good one. X to the third. Actually, yeah, this isn't that bad at all. I could totally see me doing something like this. Because what can we do immediately right now before I do anything else?
Yes.
Yeah, if you have the same, doesn't matter if it's got an exponent, this is the same number. I don't care that I don't know what that number is, it's the same number. Anytime.
What's that?
What?
That's
That's an N, yes. I'm a fantastic artist, but my handwriting. So if it doesn't matter that I don't know what X is or I don't know what N is, it's going to be the same number. That's going to be the same number and that's going to be the same number. So it's the same number. I can just get rid of it. I don't need that. Now, again, if you know the rules, it's pretty fast. I just imagine 2 X's on top, 3 X's on bottom, which means I'm going to be left with an X. You wrote it all out, it'd be X times X over X times X times X. I mean, once you do a bunch of them writing them out, you'll just start to visually see 2 X's and 3 X's, and you'll just know what's left over. So that, I'm guessing, was that the answer? Oh wait, that was the
Other than
that
that.
was an odd, right? So we're assuming that. All right, so we'll do radicals next class, and that'll be everything that'll be on Monday's quiz.
Monday.
Monday, yeah, your quiz is Monday. You didn't even say that. Quiz is Monday. You're responsible for 1 through 82, 5 through 100. I did tell you that some of the sections were not important, like scientific notation. I'm not too worried about that. So you can pretty much skip those. We skipped them today. So Yeah, put calculators back, please. Books you can just put on your desk. Let you have you don't have a thing. Actually, here, I'll fix this.
I don't know where the copy is.
Have fun. Who's the hell you got? Yeah, they tend to disappear and then show back up. So. Seminole, huh? Oh, I didn't do a tennis. 1, 2, 3, 4, 5. Who are we missing? Somebody. Oh, the other Emily. I don't even know what the other Emily looked like.
Oh, I thought you were.
You must let me get them, Mr. Gill.
What? So it might be stale. I found some that were old from last year. I can,
Now that you've already taken
what is that? I can't see the end of it. Might be 22 instead of 22. 2000. Yeah, I was gonna say I found a bunch of them, and and the way I found them is I grabbed a packet.